Welcome to lesson 11 of this Arduino C++ course, and today, as the title says, we're going to be looking at advanced servo control. We're going to be learning how to use buttons and the potentiometer to change the servo position and the speed at which the servos move, but we're also going to be learning how to simplify the code, and that means putting code into arrays and functions. So a lot of new things to be learnt today. As always, the code is available on the lessons page on the Digital Town website. Just scroll down through the various lessons and you'll find everything down on lesson 11. Click on the circuit diagram to get the bigger version. And at this point, there's a big shout out to Will's granddad, who noticed on the last lesson that the ground wire was missing between the Arduino and the breadboard. So the circuit was correct on my breadboard, but the circuit diagram was incorrect. So this has now been added in. Thanks very much for the heads up on that one. Now today we will be using the two buttons and the potentiometer. So if you need to add them to your circuit, now's the time to do it. Also, you will need the breadboard power supply because the UNO is not capable of powering multiple servos. It can only really power one at most. And don't forget, as always, the code for today's lessons is available for download. Just click on the appropriate link. So at the end of lesson 10, we had 4 servos all moving independently at the same time because we were using millis to control their timing. There is no delay in the code that is running here. So you can see we've got one servo moving slowly from one end of its movement to the other. Similar with this one, moving slightly less, and then these two servos were actually moving to random destinations. So let's have a look at the code and see where we had got to. So in lesson 10, and it was the 4th sketch in lesson 10, we had set up the various servos. We created the servo objects. We had various variables for each servo. So obviously for 4 servos, we had created quite a few lines of code just for setting up the variables. We then went into the setup where we attached the various servos, and then within the main loop we had the code for servo 1, similar code then for servo 2. If you remember, the serial print statements are commented out, and that is because the very small time increments within this code can mean that endless writing to the serial monitor can actually slow the servo movement down. So we had all of this code for all of the servos, and as you can see, it's starting to get a bit bulky. So in this lesson, we are going to reduce a lot of this code into one single function. So this is the first sketch of today's lesson, lesson 11, servo version 1. And before I start actually looking at the code, I want to explain why I'm going to do what I'm doing. In the previous sketch, I was just moving the servos using time, but that's not much of a project. The goal of a project is that the servo is triggered by buttons, sensors, potentiometers, whatever you want. So that is what we are aiming for in today's lesson. We're going to have some code that is written in such a way that various inputs can control the servos. So let's get started with the code. So as before, the servo library is being included, and I showed you in the last lesson how to do that and how to install the library if you don't have it. Then we have this initial code. Now what I have done, just to make life a little bit easier, I have left the old code in, commented out, so that you can see what is being replaced. So here we had all the different servos being set up, and all of that is being replaced by these few lines of code. But you'll notice that each item is an array. Even the servo objects are in an array. Now that might be a bit of a weird one, and some might not have even seen that done before, but yes, you can create an array of objects. Now what this means is, instead of having an individual item or an individual variable, we store multiple values in a single variable. So if we look at this array here, servo pins, I'm going to start it off with the values 2, 3, 4, and 5. So if you like, those are going to be the values that I put in, if you like, the 4 slots that are in this array. Now, when it comes to setting up the array, you will notice that I have used this word num servos. So let's have a look at what is going on here. So up here, I've set up some things called definitions. Now, don't panic, because you have actually used definitions before. Let's just bring this other sketch in, and it's only a little test thing. It doesn't actually work, the sketch, but you'll notice I've got pin mode here, and I've set up pin mode, I've got button pin, and you notice we have output. Now, if I put my mouse over output, you'll notice it has a definition of a value 0x1. So it is a definition that wherever output is seen, what you're actually looking at is the value 1. If I now put input instead, put my mouse over it again, you'll see now that it has a value, a hex value of 0. And the way a definition works is that it's a bit like search and replace on a word processor. When the compiler runs, whenever it sees input, it will replace it with 0. So coming back to my sketch, wherever the compiler sees this word, num servos, it will replace it with the value 4. So I could have written this line like this and just put the value 4 in. But the problem with that is, if I want to reuse this code, let's imagine next week I want to have 8 servos, you'll see that I can use num servos as it is in numerous ways. And if the value of num servos changes, various things change throughout my code. If I have got to keep changing the numeric value here, the code is not as reusable. So definitions are very, very useful. Now, the other problem with arrays, in an array, you have a number of elements. So let's look at this item here, servo pins. Servo pins has a number of elements. And because we have got 4 elements, let's just paste these in quick. If I want to access the information within the array, I have got to use these numbers. So if you can imagine, in position 0, I've got a value of 2. Position 1, I've got a value of 3. Position 3, which is numbered 2, got a value of 4. And position 4, which is numbered 3 because it starts from 0, has got a value of 5. Now, this is not very intuitive when you are using arrays. So what you can do by setting up this name, servo1, if I was to now copy that over and put it in there, servo1, when I put my mouse pointer over, has a value of 0. If I now take servo2 and again replace the 1, when I put my mouse pointer over, you can see that it has a value of 1. So this servo2 is exactly the same as that. but obviously it makes the code far more readable, as you will see later. So that is the reason for using definitions. Now, in my example, I have used just servo 1, 2, 3, and 4 because the servos aren't doing anything. But let's imagine you were building a robot. So servo 1, or if you like, servo 0 in the array, may be the left elbow servo. The next servo may be the left hand servo, right elbow servo, right hand servo. So by being able to create definitions, you can use that within your code. So you can now say, I want to move the left elbow servo. So if I put that value in, I know that that is the element in the array that refers to that particular item. Hopefully this will become a little bit clearer as the code moves on. So these lines now can store exactly the same information as all of these lines. Now the crazy thing about this, imagine now I want 12 servos. All I need to do is change num servos to 12. Obviously, I can create some more names if I want to. I don't have to. I could use the 0 to 11 if I was using 12 servos. I would have to add the extra pins in because obviously these are the pin numbers. And I might have to put some extra values in for the servo timer speeds. But apart from that, if I put those correct values in, that's the only change that I would have to make to change this code to run 12 servos rather than 4 servos. And that is the flexibility of using arrays in this way. Now, moving down to the setup, in the old code, we attached the 4 servos individually. This time, we're going to use a for loop. And you'll notice num servos has made it into the for loop. If I put my cursor over that, num servos equals 4. So from q, which is just a counter, equals 0 to q is smaller than num servos. So that is going to be values 0 to 3. This for loop is going to go round and we're going to take my servo object, because I've called my servo object my servos, but it is an array. So what I'm saying in this line is that the first item, imagine q is equal to 0, so that's going to be my servos 0, and I'm going to attach that to the servo pin that is then 0 in the servo pins array, which will be a 2. For the next servo, when it goes round this loop again, q is going to be 1, so servo object 1 is then going to be attached to servo pin 1, and that servo pin will be 3. Now obviously if we're using our definitions, we now know that servo 2 is now attached to pin 3, servo 1 is attached to pin 2. Sounds a little bit complicated, but it's actually quite simple. And the other thing just to be aware of here, if I wanted to have 12 servos, obviously I'm going to keep adding another 8 lines of code. With this method, if I wanted to add another 8 lines, if you like, another 8 servos, because the value of num servos will have changed, it will just go round this loop 12 times instead of 4 times, and it will automatically attach all of my servos in one go. And this is where starting to use the for loop and arrays can really shrink your code down, providing you can get your head around using arrays. Now, coming down to the main loop, what I've done is I have left in again all the original code. So for the, if you like, the timing code for servo 1, this was everything that I needed to do. There was that one other little bit of code that dealt with if the servo had reached its final position. I've left that out because obviously going forwards, we don't need that for running our servos because the servo movement could be triggered by something else. So what I've done is I've separated that code out down here after the servo movement control. So this for loop here is going to control the movement of all 4 servos, and it works exactly the same as the previous version, just instead of doing it once, it does it for the number of num servos. So again, if I had 12 servos, rather than running round 4 times, it would run round this loop 12 times. So let's just check what it's doing. Now, the first thing that I've done is I've made one very subtle change. If we go down to the old version, the first thing it did was check the timing to see if it was time to move the servo. Now, in a normal project, the servo is not moving all the time. So in this case, it's starting off by saying, is the current servo position not equal to the target position? So all it's saying is, does this servo need to move or not? If these are not the same, then the servo that it's working on does need to move. And at that point, it's going to check if it's time to move. Now, I could have put the is it time to move outside and the this sort of comparison inside. The reason I have done it this way is it's a very subtle thing, but it does make a slight difference when you're really trying to write some fast code. Because of the way the Arduino works, these are integer values. So for the Arduino to compare this value with this value, it says, is this equal or not equal to this variable? Sounds simple. Because these are unsigned longs, the Arduino, because it is a 16-bit processor, has to compare the first 16 bits with the first 16 bits of this, and then compare the second 16 bits with the second 16 bits of the other variable. So if you like, it has to do twice as much work. It's actually slightly more than twice as much to compare a long or an unsigned long as it does to compare an integer. So it's much quicker to fail it on the integer than it is to fail it on the unsigned long. For most of your code, it's not going to matter. But if you really are, racing for speed, little things like that can just give you a minor edge. Anyway, don't panic about that, because once we've done this comparison, we've then said, should this servo move? Because we're working through from servo 0 to 3. So servo 1, does it need to move? If it does, is it time for it to move? Notice we can go through the elements of the arrays, all the different arrays, just by using our variable, my little counter, which is Q. For those who've not seen my code before, Q doesn't stand for anything. It's just I'm lazy and I cannot misspell Q because it's a single letter. So it's a variable that tends to be used when I'm just counting something. And if I'm counting something within something, I'll tend to use W as the next letter. Now, once again, just as in the previous code, if the position, the current position, is smaller than the target position, then we are going to increase the value of the servo position. The only difference now is we are updating the position in the array rather than just an individual variable. And again, with the opposite direction, we reduce the value. And then instead of doing the servo 1.write to servo position 1 or whatever we wrote, we're now going, my servo object that is first in the array I'm going to write to that, and the servo position that I'm going to send is the servo position for the Q value that is going around the array. So this loop is going to run 4 times. If we had 12 servos, it would run 12 times, and it will update, if required, the position of every single servo. And it will do that extremely quickly without blocking your code. Then obviously coming down here, I've just got that bit. If it's actually made it to the end of its movement, so if now the servo position, and you'll notice now I'm using servo 1. So before, this was going through all the servos. Now I'm using the servo 1, the definitions, so that I can target a very specific set of elements within the array. So you can see I'm using servo position servo 1. Well, I know servo 1 actually has a value of 0. So it's actually checking, is the position 0 the same as 0 in the servo target position? If it is, change the servo target position to a new position, just as we did in the old sketch. Again, I've done the same, exactly the same as the second sketch now for servo 2. And then for servo 3 and servo 4, I've done exactly the same as the old sketch, in that I'm now picking random positions. Now, I hope I've explained that well enough. It's not an easy concept at times to explain, especially if you're new to arrays. But let's go to the webcam and see what we've got. So, looking at the webcam, nothing has changed. These servos are now moving in exactly the same pattern as they did before. The only difference is that our code has been reduced by quite a lot of lines of code and is setting us up for the next improvement to our code. So going back to our sketch, if we now think about our code, this little bit of code here is the bit that is controlling all of our servo movement. So what we're going to do in the next sketch is we're going to move this into a function to keep it nice and safe. So this is the new sketch, and this time I've removed all of the, if you like, commented out sections. So the variables now are just these few lines. Obviously the setup is the same, but when we now come down to the main loop, I've left in these various items that were changing the destination of the servo once it had got to its sort of last destination that was set. But you'll notice all the servo movement has been removed, and that has been replaced by this one line, and this is calling a function that I have created. Now, if I scroll down to just below the main loop, here is my custom function. Now, I'm not going to go into all the details of creating functions today, because otherwise the lesson would go on forever. So this type of function is what I would sort of use for keeping code protected. So what this has done is it has taken a section of code that was before up here in the main loop, and it has moved it out into a separate area. So the way the loop now works is that the code starts at the top of the loop as before, sets a value for current millis. It now starts to work its way down the loop, but when it comes to this function, it now immediately jumps to this, goes through the function, and in this case it's going to go round 4 times, and when it's finished those 4 times, it jumps back to its position in the main loop, and the code continues to read down through the main loop. Now, the reason for separating out this code, and is just to make life easier for yourself. So imagine I build another servo project tomorrow. Because I've got a function that now controls all servo movement, I can literally copy and paste this function into a completely different sketch, knowing that this is all going to work. So let's have a quick look at how the function is set up. The first thing to notice is this word here, void. Now that means that when this function runs, it does not return any information. To give you an idea of an alternate to that, if we think about this little bit of code, so my result equals digital read, I'll just put in pin 4. So imagine now, not particularly well spelt, in my code on pin 4 I have a button or whatever. This function, digital read, returns an integer value of my result. In that case, this here would have said int, because it's going to return a value. However, this particular function does not return any value, so it starts with the word void. And if you are doing any code where you, if you like, you were just moving some code aside to protect it, you would put void in here. Now the other thing is, you'll notice that there are some brackets after the name of the function. This is where you would, if you like, put some information if you were sending some information across, but for this function no information is being sent, therefore this is left empty. And we'll look at some more functions in some later lessons, but basically this has now allowed this code to be separated out. And the reason for that is, at the moment I am using time, if you like, oh, I'm waiting for something to finish moving and just setting a new position. What I now want to do in the following sketches is get rid of this, and I want to be triggering the servo movement using either the buttons or a potentiometer. So now that the movement code is all sorted out and that's in its own function, let's get on with those buttons. So coming back to the camera, I've got these two buttons with their pull down resistors. That means that their default value will be 0. If the button is pressed, they will give a 1. And then I've got this potentiometer that I've put in here. So the next sketch is a very simple sketch, and all it's going to do is just test the button and the potentiometer. Because if I don't test these buttons and the potentiometer, I can start writing miles of code and have some bugs and not know, is it my code or have I not connected up the circuit correctly? So very simple. I'm going to have a timer that's going to run every half a second. I have set up the button pin. The left button is button pin 8, right button pin 9. Potentiometer is on analog pin 0. In the setup, it's the usual, set them both up as inputs. You don't have to do anything for the analog read. And then finally, coming down to the main loop, I've got current millis equals millis. So it's a timer circuit. It's running every half a second, and it's just going to check the state of the button and see what's going on. So let's quickly run the code. So we can now see that the serial monitor is running away. If I press the left button, I can now see that the left button is giving a value of 1. Release it, it goes to 0. Right button, once again, get a value of 1, so I know that's working. And then if I just adjust the potentiometer, you can see the value of the potentiometer slowly increasing. So now that I've confirmed that the buttons and the potentiometer are connected correctly and I'm getting the results I expected, I can now go back to my sketch, and we're now going to integrate those into the latest sketch, which is the Servo version 3. So again, all of this code remains the same at the top. All the variables to do with the servos remain the same. The big change, obviously, I've set up these pins. I've got the constant integer for the left button, the right button, and the potentiometer, which is on analog 0. I've got a new unsigned long button millis because we're using buttons, and therefore we are going to be debouncing them, and I'm going to be debouncing them at a 350 millisecond gap because I'm getting old and I'm slow on the buttons. Moving down to the setup, all of this remains the same. The only difference is that I have set up the pin mode for the 2 buttons. Obviously, the potentiometer does not require a pin mode because it's an analog pin, but the 2 buttons need to be set up as inputs ready to be read. Now, it's at this point that the fun starts, and I hope that the code that you're going to see here will help you in your projects going forwards. So as always, the main loop is starting off with current millis. I've got this integer for a button state that I will be using when reading the digital pins, and the pot reading is the reading that comes off the potentiometer. I've then called servo movement control. You'll notice this is right at the beginning of the loop, and this is instantly looking, are there any changes to the position of the servos that need to be made based on the inputs that we will put in place in a moment. So once that's done, we're then coming down to our first inputs. So this in many ways is a repeat of the code that we covered in lesson 5, where we debounced buttons. So we are reading the state, we're doing the digital read as it says here. This was covered in lesson 5. If the button state is greater than 0, we're then resetting the debounce timer. And then all I'm doing is saying if the servo target position is greater than 0, set it to 0. But also notice I'm also setting the servo timer. Now, if we go back up to our variables, when I set up these variables, the servo timer variables change the speed at which the servo moves. So what I'm doing for this particular bit of code here, where are we? There we go. I'm setting servo 1 to have a value of 0. That means that there is no, if you like, wait between the movement of the servo from one step to the next. So the servo is literally going to move as fast as possible. And this is the great thing, I can just call the position because I don't need to remember that it's a 0 anymore. It is 0, but I don't need to remember that. All I need to know is it's servo 1 that I want to change the speed on. It's servo 1 that I want to change the position on. And again, the alternative is I'm going to set the servo position to 179, but in the other direction, I'm going to set the servo speed to 50. So in one direction, it's going to go flat out, and in the other direction, it's going to go slowly. So let's have a look at the code running. So servo 1 is this servo here on the far left. Here is my button. So if I press the button, the servo moves slowly. That's at a speed of 50, and it is moving over to a position of 179. And once it gets there, it's just going to sit and wait because it's reached its destination, and until it's given a new position to go to, it's just going to sit there forever. This is why these other servos aren't currently moving. If I press the button again, notice that time it moved flat out. That's because we had set the speed down to 0 and obviously the position was set to 0. So in one direction, we're controlling the speed and position. We're moving slowly to 179. Now, if I press it before it gets there, let's just bring it back. Let's start it moving. And now I'm going to press the button again. Now at that point, you notice it jumps back immediately. And that's because a new target position has been given and the servo doesn't care where it was going to before. It's now heading back to the new instruction that I've given it. So that is an idea of how to control speed and position with one button. What I'm now going to do is take you down to button 2. And you'll notice here that button 2 is going to control 2 servos. So when button 2 is pressed, servo 2 is going to go to 0 with the speed of 30, while servo 3 is going to go to 179 with a speed of 30. And when I click it the other way, obviously, next time it will reverse. So this means it's going to control 2 servos. They are going to move in time with each other, but in opposite directions. So let's watch that code run. So the 2 servos are these 2 here. I should have put the tops on to match, but still, you'll see as I press the button, they head in opposite directions. Press the button again, they go back in opposite directions. Now, while these are working, obviously button 1 can still be triggered anytime I want. And the same with these servos. If I suddenly want to reverse the position, I can change the position anytime I want. So my final control is using the potentiometer. Now, we used analog read in lesson 6, and also in lesson 6 we learnt to use the map function. So we're going to take the potentiometer reading. That's going to give a value between 0 and 1023. But our servo requires values between 0 and 179. So on this map function, we are remapping the 0 to 1023 onto a value of 0 to 179. So if you like, the percentage of movement through between 0 and 123 will be the equivalent. So 1023 will come out at 179, 0 will come out at 0, and whatever is halfway between those two numbers will be halfway between these two numbers. So we're changing the pot reading by going through the map function. The output of pot reading will be a value between 0 and 179. Coming back to the webcam, the servo being driven by the potentiometer is this one here. It's a little bit grumpy. You'll notice it is flickering slightly, and that is because of the potentiometer. The readings are not particularly great off this. If I start to turn the potentiometer, you can see that the servo then moves to a new position at a slow rate. I'm going to ram it straight over the other side. I've deliberately got it moving slowly so that it takes a bit of time to catch up. Every time I move to a new position, it will instantly change its direction and will start aiming for that new position. Now, at the same time all of this is going on, obviously I can start pressing all of the other items. Everything will work together. So now I hope that you can see that just by including this very simple function within your code, you can now control the movement of multiple servos independently, or as we've seen here, in sync with each other, even if you want them moving in opposite directions, and their speed and their destination can be controlled at any time you want. So what I could have done is I could have used the potentiometer and use that to change the speed setting while using the buttons to control the movement, the direction settings. You could flip this round however you wanted. Rather than this being a button, it could be a PIR sensor. If I was building a model railway project, let's be honest, if we were doing a level crossing, this may be some kind of sensor, probably an infrared sensor, something like that. That would send one crossing gate in one direction, one crossing gate in the other direction, because obviously they lift differently depending which side of the road they're on. And when the sensor is no longer triggered, I could then move the crossing gates back where I wanted them. In that case, I wouldn't be using these names, Servo 1, Servo 2, etc. I would be using something like crossing gate left, crossing gate right. But the important thing to get out of today's lesson is to understand that if you use non-blocking code for your sensors, buttons, potentiometers, whatever, and for your servos, you can be reading your inputs while driving your servos and other components at the same time, and you can build some really, really nice projects. And by doing the code the way that I've written it today, once again, if you want to add some more servos, let's make 12 servos. Change that to 12, add some more definitions in, add some more pins, put some more speeds in, and you're ready to go. The rest of the code will look after itself. Add some more triggers, however you want, but it is that simple to use servos in quite complicated ways if you just use this type of code. So quite a complicated lesson today. We've looked at a number of new things. We've looked at definitions, we've set up a function, we've gone into some basics of arrays. It can be a lot to take in, so have a play. If you haven't got 4 servos, maybe you've only got 2 servos, put 2 servos in. Maybe you've only got 1 servo. Set the board up with a single servo and control that with your buttons and potentiometer. If I was doing this with a single servo, I would use 1 button to move the servo in one direction, 1 button to move the servo in the other direction, and then use the potentiometer to change the speed of movement. The code is exactly the same, you'll just change num servos down to 1. Anyway, hope that's been useful for you. Again, if you've got any questions, stick them in the comments, and if I need to, I'll add an extra video in to explain the finer details if required. So that's it for today. Hope you've enjoyed it, and I'll see you in the next video. Bye for now.